we have the points 15, 3, and 24, negative 8. The x-axis is between 3 and negative 8, somewhat closer to 3, so I've sketched what might be a picture of the x-axis here, and mostly I've just sketched this for reference. The y-axis doesn't even appear on this board. It's over to the left a good ways, because from 24 to 15 is a distance of 9. If we go that far again, we're already off the board and we're not back to 0. So the y-axis doesn't appear. I throw in the x-axis so we know which is the horizontal direction, and the vertical direction is, of course, perpendicular to that. Now, we want to sketch, first place, a line segment between these 2 points. So you should stop and draw this picture yourself and do that. Okay, I've done so. There's a line segment between the 2 points. Now I want to construct a triangle whose legs, I want to construct a right triangle whose legs are parallel to the x and the y axes. So can you do that? Can you construct a triangle having this line segment as its hypotenuse with 2 legs, one parallel to the x-axis and one parallel to the y-axis? Okay, you don't have to see the y-axis to know that it's going to be perpendicular to the x-axis. Okay, I've written those criteria out. The segment from 15,3 to 24, negative 8 is hypotenuse. Legs are parallel to the coordinate axes. So, hopefully you've drawn that, but if not, again, pause and be sure that you do before you go on. Okay, now one possibility is that the vertical leg runs from 15,3 in the downward direction until it joins a leg from 24,8, which runs in the horizontal direction. And of course, this is going to be a right triangle since the coordinate axes are perpendicular to one another. Now there's another triangle. You could have easily, just as easily, sketched the triangle. I'll just do this lightly, where the horizontal leg goes from this point and the vertical leg is here. So this triangle is just as good as this triangle, but since I drew this one, that's the one we're going to use. And you would see what to do with the other triangle. Okay, now I want you to label these 2 legs with their lengths. What's the length of this leg? What's the length of this leg? Be sure you think that through before you watch what I'm about to do. Okay. Well, the length of this leg, we go from 3 down to negative 8. So the length is from 3 down to negative 8. Well, you got 3 units down to the axis, 8 more units here. The length is not 8, it's 11. Let me fix that. Okay, the length is 11, and I'll also note that the directed length is negative 11. If we go from this point to this point, we're actually going negative 11 units in the downward direction. Now, what's the length of this one? Well, clearly we're going from 15 to 24. That's a distance of 9. So the length is 9. And the directed length is also 9. Now that we know the sides of the 2 triangles, we can find the length of the hypotenuse. You should think through how to do that. To have a leg of length 9, 11, and a leg of length 11 and a leg of length 9, then what's the length of the hypotenuse? Well, we know the Pythagorean theorem. So, the Pythagorean theorem says that the hypotenuse squared equals first leg squared plus second leg squared And that's often written as c squared equals a squared plus b squared. Probably the way you learned it, very likely the way you learned it. But that would be the two legs, because the a and the b are the legs, and the c is defined to be the hypotenuse. Okay, so the hypotenuse is the square root of leg 1 squared plus leg 2 squared. So the hypotenuse here has length, what? Square root of 11 squared plus 9 squared. Now, 11 squared is 121. Side has length 81, so we get the square root of 202. That's the length of the hypotenuse. Now, what's the slope of our segment? Okay, well, when I say slope, what's the first thing you think of? Now, actually, in class, I didn't get an immediate response, but the first thing that you think of, if you want to understand what slope means, rather than quoting a formula, which is something you're not likely to remember for long, slope is rise over run. Now, what's the rise of this segment? Well, to get the rise, you got to decide if you're going to go from this point to this point, or from this point to this point. Now, usually we go from left to right, but it's going to work equally well if you go from right to left. Still, I'm going to go from left to right. Okay, so what's the rise? Well, the rise is the vertical displacement. In other words, the directed vertical distance. In this case, the rise is negative 11 because you got to go down 11 units before you go right 9 units in order to get from this point to this point. So the rise is going to be negative 11, and the run is going to be, well, it's going to be the 9 units that you go in the horizontal direction. So there's your slope. It's negative 11 ninths. Now, we can get that by a simple arithmetic process. Just to confirm, our rise is going to be from 3 to negative 8. Okay? We get that by a simple subtraction. We do negative 8 minus 3. This y coordinate minus this y coordinate. And it's negative 11, confirming that our belief that the rise is negative 11. So there's an easy way to calculate it. You just subtract where you're at from where you're going to be. Okay, now the run is what? How would you express the run in a similar calculation? Be sure you have an answer in your head before you watch what I do. Okay, well, the run is going to be 24 minus 15. Which is 9. And of course now the negative 11 goes here, the 9 goes here, and we again have our expression for the slope. There's one more thing that we can get pretty easily from this picture, and that's the coordinates of the midpoint of our segment. Well, the midpoint of our segment is a segment halfway between the 2 points, and probably somewhere around here. So the midpoint is here. What are its coordinates? Okay, so how do we get the coordinates of this point? Let's start by drawing a triangle from the 15-3 point down to the midpoint. So I've done that. This green triangle represents that construction. What are the sides of that triangle? Again, get an idea, get a thinking, get your opinion, and let's see if it's right. Okay, well, this triangle is going to have half the dimensions of this triangle. That's going to get it from here halfway down here. It's going to be similar to this triangle, but with half the dimensions. So this side of this triangle is 11. We have a directed length of negative 11. The directed length here then is going to be negative 11 halves. And over here, well, the length and the directed length are 9, so we're going to have half that length. That's going to be 9 halves. And now, knowing that the directed length from this point down to here is negative 11 halves, and from here over here is 9 halves, starting from 15 thirds, or 15.3, what are the coordinates at which we end up? Once more, you should figure this out before you watch me do it. Well, from 15.3, we go down 11 halves and over 9 halves, ending up where? Okay, well, we have the 15, which is the horizontal coordinate, so we're going to add 9 halves to that to get the horizontal coordinate of the midpoint. And we're at 3 here, and we go negative 11 halves from there. So we have 3 minus 11 halves. And that equals what? Well, 15 is 30 halves. Add 9 halves, you get 39 halves. And subtract 11 halves from 6 halves, you're going to end up at negative 5 halves. And that would be 19 and a half, which is between 15 and 24, and it's halfway between, and negative 5 halves, which is negative 2 and a half, which is between 3 and negative 8. Another way to find the midpoint, and more convenient than constructing this triangle, but it's going to give you the same result, is simply that your x-coordinate is going to be halfway between 15 and 24. So going just from here to here to here in the horizontal direction, we have to go equal distances. Now what's halfway from 15 to 24? Well, that's going to be, don't really have a lot of room to write that. I'm going to write it here. It's to find halfway between two numbers, you add them and divide by 2. In other words, you just average the two numbers. So 15 plus 24 divided by 2. 15 plus 24 is 39. So that's 39 halves. And then halfway from 3 to negative 8, you add 3 and negative 8, you get negative 5. And I didn't write out the calculation, but you just average 3 and negative 8. You do get negative 5 halves, and notice then that the 39 halves matches what we got here, and the negative 5 halves matches what we got here. Okay, so we see that by constructing a segment between any two given points, we can construct a triangle whose directed distances are the rise and the run. We can use the lengths of the rise side and the run side to get the hypotenuse. We can use the rise and the run to get the slope, and then we can construct a triangle to the midpoint whose directed lengths will just be half of those of the original triangle and displace accordingly to get the midpoint. Or we can average the two x coordinates and average the two y coordinates to get the x and y coordinates of the midpoint.